Hello everyone, welcome to Polyset Ritual Training. Today we are going to discuss about real numbers. What are real numbers? Real numbers consist of rational numbers, integers, whole numbers, natural numbers and irrational numbers. Now let us see in detail what are this. Natural numbers. What are natural numbers? When I can count the numbers, for example, 2 apples, 3 apples, 7 apples, like that I can count it, right? The counting things are also, counting numbers, always you will say it as what? Natural numbers. Always natural numbers starts from 1. Okay, you will represent as capital N. Capital N is a collection of numbers which starts from 1. Then what are whole numbers? If I include 0 in the natural number. So what are natural numbers? As we know, yes, it starts from what? 1, right? If I include 0 in that, then you will say that as a whole number, right? As you know, it's a symbol representation as capital W, right? Next, we are going to see about integers. What are integers? Integers are nothing but it's a collection of positive and negative number. What is positive and negative number? Positive number is a number with the plus sign. You can see here, right? 1, 2, 3. A number doesn't have any sign. You will add that, you will say it as a positive sign. Here you can read it out, right? -2, -3. So these are the negative numbers. It's a combination of what? Positive and negative numbers that are called integers. Now we are going to see about rational numbers. What are rational numbers? Any number can be written in the form of P by Q. It can be said as rational numbers, where what they have given, where Q should not be equal to 0. Why it is so? If I have taken, here you can see, right, 5 divided by 0. If any number is divided by 0, obviously answer is what? Undefined. So you can't define the answer, right? So that's why they are said you very clearly here, Q should not be equal to 0. A number can be written in the form of P by Q. You will say that as what number? Rational numbers. For example, if I'm taking 2, so I can write it as what? 2 by 1. Right? Next, we are going to see about irrational numbers. What are irrational numbers? All numbers which are not in the form of P by Q, which cannot be written in the form of P by Q. You can say that as what? Irrational numbers. So generally what we will say for these irrational numbers is numbers under the root. For example, root 2, right? Root 3 and root 4. Here you have to be very careful. If I have given the root 4, so is it a irrational number? Obviously no. So the numbers with under the perfect root numbers won't be the irrational numbers, because root 4 answer will be what? 2. Right? They might ask you in your examination, they might give you some numbers like root 3, root 5, root 7 and root 81. Find the irrational number or irrational number they can give you. So you have to take a combination. If it is a rational number, even though if it is under the root, you can write 81 as what? 9. So it's nothing but 9 by 1, right? Next, we are going to see about terminating decimal, recurring decimal, right? Let us discuss that. What is terminating decimal? What is mean by terminating decimal? What is mean by terminating? As you know, yes, exactly. As you know, terminating means ending. Right? It will end, right? So we should have a finite number of digits after a decimal place. What is mean by finite? It should be stopping at 1 point, right? For example, if I'm saying 2.13, it is a finite decimal. If I'm saying 2.133333 like that, so obviously it is not a finite decimal. So it should be a stoppable, right? It should be terminating. Then term should be terminating. So here you can see that, right? 0.375 gives you what? 3 by 8, right? After 0 point, you are having how many decimal places? You are having 3 digits in the decimal portion, right? Here you can see 7.2459. Here you are having 4 digits, right? After 9 point, you are having 1 digit. So any number, a terminating decimal is nothing but a decimal place should be what? Finite number of digits should be there in the decimal place. That is called terminating decimal. Next, we are going to see about repeating decimal. What does mean by repeating? A repeating decimal is a decimal that has a digit or group of digit that repeats. Okay, here you can use the word recurring also. Repeating or recurring. You will say that as what? Recurring also. So repeating or recurring, it gives the same meaning, recurring. So repeating decimal means what? A decimal that has a digits or group of digit that always repeats. Okay, so to show that what we will use a bar. We will use a bar on the top of the number. You can see here, if I'm dividing 1 divided by 3, what is the answer? 0.333. So 3 never stops, right? Goes on, 3 is repeating. The same number is repeating here, right? So what can I do over here? 0.3 bar. This bar shows that 3 is repeating endlessly. Right? Same way here you can see 3 by 11. If I take 3 by 11, 0.2727. So 2727 is going on repeating, right? So what is the repeating decimal over here? 27 is here repeating. So what you have done over here? Upon the 27, you have kept the bar over here. Right? Now we are going to see about non-terminating decimal. What is mean by non-terminating decimal? Yes, obviously you know. Terminating means what? Having endpoint, right? Here non-terminating what? Obviously opposite to that, right? Without having an end term. A decimal number without an end term. It never stops. That you will say it as what? Non-terminating decimal. For example, see here, we have divided 11 by 9, right? So if I'm dividing 11 by 9, what I'm getting over here? So first, in 9, 11. So one time I'm taking up, right? So 20. Goes on, it is repeating. Could you see that? Once again, it started the reminder as what? 2. Once again, what I'll do? I'll do add 0 and I'll take up once again 9 2s are 18. Like that, it will go. Could you see over here that 2 is going on repeating? So what you will say this decimal as? You will say this decimal as a non-terminating decimal. So how you can write it? So 1.2 bar. Means this 2 is going on repeating. This decimal never have any ending. This is called non-terminating decimal. What is mean by recurring or repeating decimal? A repeating decimal is a decimal that has what? Digits or group of digits that repeats. Usually you represent that number upon that bar. You will use the symbol bar. Okay. Non-terminating decimal means what? A decimal number without an end term. You will say that as a non-terminating decimal. Right. Now we are going to see non-terminating, non-repeating. As you people know what is non-terminating now? Non-terminating is nothing but what? A decimal number without an end term. What is mean by non-repeating? We read about recurring or repeating. Repeating means what we read? Actually we know that it is going to be a same number will get repeat, right? But here what will happen is we never get the same number. Okay, you will have a different repetitive digits. So what is that is called? A decimal number that has neither end nor have any repetitive digits. Okay, so it doesn't have what it doesn't have actually. It never have any ending or any repetitive digits or group of digits. Okay, because we know that, right? What we know before only we know that if it is a repetitive, we will keep what? Bar. But is it possible for you to keep a bar over here? Obviously not. You can't do it because the same digit is not repeating. For example, if I'm taking the value of pi, what is the value of pi? 3.141592 goes on, it will repeat, right? If it is a root 3, 1.732050, see, you can see over here, the same digits are not repeating. The different digits are repeating over here. This is called what? Non-terminating, non-repeating decimals, right? Next, we are going to see about how the non-terminating decimals we can classify it. So, non-terminating decimal can be classified under two categories. One is what? Repeating decimal. Another one is non-repeating decimal. What does mean by repeating decimal? As you people know, a decimal, a group of digits in the decimal number, a group of digits or a digit, it will get repeat, right? That is called repeating or recurring. Non-repeating means what? It won't get repeat. Next, the decimal, the recurring decimal, we can convert into what? fraction, but here you can't convert into the fraction. So this number called rational number, it will come under which number? It is rational number. So simply they to tell you that this decimal can be written in the form of p by q, but it will come under the form of what? Irrational number, right? Irrational number, non-repeating decimal, what you will say? Irrational number, like root 3, like root 2, right? Root 5, like that you will say it as a non-repeating decimal, right? Next we are going to see how the repeating decimals we are converting into fraction. Let us see through the example. Okay, they have given us 0.7 bar, right? 0.7 bar. As you people know, bar means what will happen? The same digit is going on getting repeating, right? Here you have to remember only one thing. What you have to remember? If one digit is repeating, then you have to multiply that number by 10. Okay, if 2 digits are repeating, then it should be with 100. Then 3 digit means 1000. Like that, how many digits is repeating, you will multiply with that, right? So first what I'm considering, whatever they have given, I have taken it as x. So by removing the bar, what I have done? 0.7777, like that it is going on and dot I kept, right? So as I said you in the starting itself, only one digit is there. So what you will do? You will multiply the x with 10. If it is 2 digit, you will multiply with 100, right? So what I'm doing over here, I'm multiplying this equation 1 with what? 10. Okay, if I'm multiplying with 10, what will happen? Your decimal place will shift to 1 to left, right? So 7.777 it is coming. So this is turning as what? Equation 2. If I subtract these two equations, if I subtract this, what I'm doing it? If I'm subtracting these two equations, what I'll get it? 10x minus x. 10x minus x. If I'm subtracting this two equation, I'll get it as 10x minus x is equal to 7. Right? So 9x is equal to 7. So x is equal to what? 7 by 9. So how you can convert the repeating decimal or recurring decimal to the fractions. See here, how many digits is repeating over here? Bar is given under 5, 6. So what is that? How many digits are repeating? 2 digits, right? So what you will do over here? You have done with 100 multiplication. If I am doing the 100 multiplication, this 2 digits will move to towards your left, right? So what you will do? First step, as you people know, let x is equal to 1.2565656 is repeating, so I'm writing 5656 like that. Next, if it is a 2 digit, we will multiply with 100. So 100x is equal to 125.656565. So as usual, what I have to do now? I have to subtract this 2, right? So if I'm subtracting this 2, 99x is equal to 124.4. Right? So x is equal to 124.4 by 99. But I can't get the answer in the decimal. I need the answer as a fraction. What I'll do? To remove this one decimal place, I can multiply and divide by 10. Multiplying and dividing by what? 10. So what I'm doing? Up also I'm multiplying by 10. Down also I'm multiplying by 10 with this 99. So what is the answer? You will get it. So if I'm multiplying with 10, here also I'm multiplying with 10. Right? So that you will get 1244 by 990. If I'm simplifying this, I'll get answer as 622 by 495. Right? Hope so it's very clear to everyone now. So let us see some terminologies what you have to know in real numbers. First is algorithm. What is meant by algorithm? Algorithm is a series of well-defined steps which gives a procedure for solving a certain type of problem. What we have done in the previous problem, right? We got a recurring decimal. Through that, how we converted into fraction? First, what we have done, whatever they have given, we have considered it as what? X, right? Then if it is a 1 decimal place, what we have done? We have multiplied with 10. If it is a 2 decimal place, we have multiplied with the 100, right? Then we subtracted the two equations. Through that, we got the X value, right? That what we have done, step by step we have done, right? So that is called what? Algorithm. Algorithm is nothing but it's a series of well-defined steps which gives a procedure for solving a type of problem, right? Then we are going to see about lemma. What is meant by lemma? Lemma is a proved statement used for proving another statement. Okay, what is a lemma? A lemma is a proven statement used for proving another statement. So already some proof will be there. I'll use that and I'll use it the same proof for the another proving. Right? That is called lemma. Now the important topic what we are going to see over here is Euclid's division algorithm. What is meant by Euclid's division algorithm? Let us try to understand it. Whenever you are doing the division, right, we know one method to check it. What is the method we know? What we will do? Dividend equal to divisor into quotient plus remainder, right? This is the way we will check our division, whether we have done right or wrong, right? The same thing is taken as a Euclid's division lemma. What is that? A equal to BQ plus R. What is that? A equal to BQ plus R. What is A here? A is nothing but dividend. Right, what is B? It's a divisor. What is Q? Q is a quotient. What is R? R is a remainder. So the same division, how we will check our division, that is only we'll say it as what? Euclid's division algorithm. So it's nothing but A equal to BQ. What is that? A equal to BQ plus R. Okay, this is a Euclid's division algorithm. Then where we will use this Euclid's division algorithm? We will find the HCF. If you want to find the HCF, what we will do? We'll use this Euclid's division algorithm. Right? As we know, this is lemma. We learned, right? Lemma is nothing but some proof. We will use it to find the other things. So this is HCF. To find the HCF of two numbers, you will we'll use what? Euclid's lemma division. Right? So let us understand this through example. Okay, Euclid's lemma division, as we know, what is it? A equal to BQ plus R. Right? So what we are going to do? We are going to find out the HCF of 42 and 64. How can I find it out? Let me do that step by step. Okay, first what we have to do, see the two numbers. Which is the greater number? Take it as a dividend. Out of 42 and 64, which is the greater number? 64, right? So what I'm doing, I'm taking as a 64 as a dividend. And this is what? Divisor. Dividend is a number which I have to divide it. Divisor is a number by which I will divide it. Okay, so what is it? 42 I have taken. Now I'll check. In 42 table, 64 will come how many times? Obviously, 42 ones are 42, right? 42 twos are 84. Okay, 42 twos are what? 84. So I'm getting more than 64. Obviously, which how many times I have to take it? 42 ones are, right? So 42 ones are 64. What is the remainder I'm getting? 22. Right? So next step what you will do, the first step, previous step, divisor will turn as a dividend. What we are doing it? Previous step, divisor. What is a divisor in the step? 42, right? 42 will turn as a dividend in the next step. Then remainder will change as a divisor, right? So what we are doing here? 42 we are taking and 22 will be your divisor here. So 22 tables, 42 will come how many times? Only one time. The remainder will be what? 20. Yes, as you people know right now, what you will do? 22 will change as a dividend and 20 will change as a divisor. So in 20 table, 22 will come how many times? One times. The remainder will be what? 2. Once again, what we are doing? 20 is turned as a divisor and 20 is turned as a dividend and 2 is turning as a divisor, right? So 2 into 10 plus where we are getting remainder as 0, that particular divisor, it's a HCF, right? In which step we are getting remainder as 0, that particular step what we will have? That divisor we will say it as a HCF. So what is a here HCF of 64 and 42? It is 2. Right, here what you have to remember is always first consider what is the greatest number should be the dividend and smallest number should be the divisor. Okay, in each step what you will do? First step, divisor will change as a dividend in the next step and remainder will change as a divisor. In which step you are getting remainder as 0, that divisor will be your HCF. Right? Next, we are going to see about LCM and HCF in the long division method. Okay, how to find out the LCM and HCF in the long division method. So find the LCM of 24 and 36. How you can do the LCM is, as you people know, 24 and 36, right? 24 and 36, 2 table, both will come in 2 table, right? Or 3 table also, you can take it, it's your wish. So 2 12s are and 2 18s are. Once again, this will come in which table? 2 table or 3 table. It's your wish, you can take it with any table. So 2 6 are, 2 9s are. Once again, 6 and 9 will come in 3 tables, right? 3, 2 are and 3. Till getting the prime factors, you have to repeat this division. Okay, so what is the LCM? Now we will get it 2 into 2 into, see, 2 into 2 into 3, this also 2 into 3. You will multiply all and you will write it, right? So in the same sum itself, how can I find out the HCF also? It's very easy, right? See, you can see this 2 2 3. What is this 2 2 3? This is 3 factors when both numbers are divisible in 3 factors, right? So in 2 table you can see 24 and 36 when same way 12 and 18 is divisible by 2, right? 6 and 9 is divisible. So this number alone, what you will do, this alone you will take it as what? HCF, right? You will take this number alone, what? HCF. So 2 into 2 into 3 equal to 12. So in the same problem, you can do the HCF also or LCM also. LCM means you will consider what? Everything you will consider and you will multiply all the factors and you will write it. But in HCF, only the common factor you will consider. See, 2 is multiplied. See, 2 is a factor of 24 and 36. Same way, here 2 is a factor of 12 and 8. Same way, 3 is a factor of 6 and 9. Okay, so like that you have to find out the LCM and HCF. Next we are going to see about LCM and HCF, how you can do it, how you can express it with the powers, right? How you can express the factors with the powers. Let me see that. 336 and 54. What I'm going to do over here? 336, I'm going to take it separately. If I'm taking this 336 with the 2 tables 168 times, then 2 table 84 will come, once again 2 table 42 will come, then 2 table 21 will come, and 3 table 7 times, still getting 1, I have to do it. So how many 2s I'm getting it? 2 into 2 into 2 into 2 into 2. So 4 times, right? So you can write it as 2 to the power of 4. How many times the same number you are multiplying? 4 times, right? So 2 to the power of 4. Then how many times 3 you are getting it? Only 1 time. So I have written 1 over here. So what is how many times you are getting 7? So 1 time. So I have written 1. Okay. Same way, let us check for the 54 also. 2, 27, right? 3 9s are, 3 3s are, then 3. So how many times we are getting 2? 2 we are getting it 1. But how many times we are getting 3? 1, 2, 3. Right? So it is 3 to the power of 3. Through this, how can I find my LCM and HCF? When you are taking the LCM and HCF, you have to consider for HCF, you have to consider the least power. For HCF, what you have to consider? Least power. To find the HCF, first check this both factors are available in the number or not. 2 is available here also and here also. Yes, it is under, it will come under what? HCF. Same way I'm checking with 3 available here also and here also, right? 3 is a factor of 336 also and 54 also. Same way 2 is a factor of 336 also, 54 also. That's why I'm considering 2. So whenever you are seeing the power 4 and 1, for HCF you have to take the least power of the number. So out of 4 and 1, which is the least power? 1, right? So 2 power 1 into 3 power 1. That gives you what? 2 power 1 is nothing but 2. 3 power 1 is nothing but 3. So 2 3s are 6. Right? So let us do the LCM. How you can do with the LCM? Right? In LCM, you will consider with the highest power. What you will consider? You will consider with the highest power. Let me check. So what is a common thing? 2. 2 and 2. So what is highest power of 2? 2 power 4 I have taken. Next common is 3 and 3. So what is highest power of 3? 3 power 3 into whatever leftover factor also we have to consider in LCM. HCF, what you will do? You will consider only the common factors. That too you will consider the power of least power. Okay, but in LCM also what you will do? You will consider the common factors with the highest power and whatever the leftover factors also you will consider. So 2 power 4 into 3 power 3 into 7. If I multiply this all, you will get 3024. Okay. Now we are going to see the relationship between HCF and LCM and the product of number. This is a question you can ask you in your Polyset entrance also. It's a very important concept. How they will give? They can give you the product of two numbers and they can give you the LCM and they can ask you to find out the HCF, or vice versa they can do, right? So what is the relationship? HCF into LCM gives you what? Product of two given numbers. What is the relationship? HCF into LCM. If I multiply HCF and LCM, that will give you what? Product of two numbers. Or you can say that HCF into LCM is nothing but first number into second number. If you want to find out the LCM, what you will do? First number into second number by HCF. Same way. If I want to find HCF, you will take what? First number into second number by LCM, right? Let us try to understand this problem. Try to understand this relationship through one of the problems. So what they have given, the product of two number is 432, right? Find their LCM if HCF is given. So what is the relationship we know? LCM into HCF. LCM into what? HCF equal to what? Product of two numbers, right? Number 1 into number 2. Okay, product of two numbers, number 1 into number 2. So what is a product of two numbers they have given here? They are asking you to find LCM only, right? LCM into what is HCF they have given to you? HCF is 6 equal to what is a product of two number? 432, right? So what is the LCM now? LCM equal to 432 divided by 6. If I cancel this, what is the answer I'll get? It 6 1s are 6 7s are 42, right? Carrying on 6 2s are. So it will be 72. What is the LCM now? 72, right? Quite equal to 9. What is this form is called? It's called the exponential form, right? So here what you will say, this as a base, 3 as a base, right? And power 2. This you will say it as what? Exponent. That gives you answer as what? 3 into 3. Okay, so you'll get answer as what? 9. So how can I write this as a logarithmic form? So this you will take it as log of, what is a base over here? 3. So that will come under base 3. Okay, for log also, what is a base number? The same base you will write it, right? So this you will say it as an argument. This, what is the answer you are getting? What you will say? That as an argument. Your power, whatever the power we are getting, whatever the exponent we are getting, you will get that as an answer. So how will you read this? Log 9 to the base 3 gives you what? Equal to 2. Right? So logarithmic form is nothing but when I can able to rewrite the exponent form to get the logarithmic form. Right? Now we are going to see about the logarithmic rules. What are the rules we are going to see over here? First, here understand these things when the bases are same. When the bases are same. So when the bases are same, if I multiply two log numbers, right? What I can do? I can add that. Right? So for example, if I'm saying that log 3, 5, log 5 into 3 to the base 3. Okay. So how can I write this now? Log 3, log 5 to the base 3 plus log 3 to the base 3. Right? Same way, when I divide the number, I can write it as what? Subtraction. If I'm getting the power to power, for the argument, if I'm getting the power, then this power will come before the log. Whatever the answer you are getting for log 1, always, it's an important question. Always the log 1 is how much? Whatever you can take it as a base. But the log 1 will be what? Equal to 0. Right? When the base and the argument is same, then the answer will be 1. For example, if I'm taking up log 7 to the base 7. So what is the answer? You'll get it equal to 1. Right? Whenever the argument and the base is same, you will get answer as 1. Right? Same way here, see, you can see over here, right? See, base and the argument is same. So obviously what will happen? It will changes. First we will apply what? Power rule, right? So this k will go here. So now the argument and the base is same. Your answer will be 1. So k into 1 gives you what? K. Okay, so b to the power log b k. So what is answer you'll get it? You will get answer as 7. Here you have to remember one important point. Always the base should not be not equal to 1. What it should not be? The base, whatever b you consider over here, no, log base should not be not equal to 1. It should be greater than 0, but it should not be not equal to 1. Whatever the number you are multiplying or dividing, it should be the real numbers. It should be the positive real numbers. You have to remember this. This is a very, very important for your exam point of view. These are the, then we are going to see about characteristics. What is mean by characteristics? You can see over here, right? Log 15 to the base 10. So what they have done here, 1.176091. So they express this log number in the form of decimal, right? Whatever the whole part, this you will say it as what? Decimal part, and you will say this as a whole part. This whole part you will say it as what? Characteristics of the logarithm, characteristics of the number. And this decimal part, this whatever it is coming in your decimal number, that you will say it as mantissa, right? Your whole part you will say it as what? Characteristics, and whatever the decimal part you are getting it, all the numbers you will say it as mantissa. So let us see one problem. Solve for x. So 7 power x is equal to 3. So where it is? The x is in your exponent, right? So we know when you get the answer as a x, what is the answer you can get it. So could we try to write this as a log? So what is the answer you will get it? Log 7, right? Base number will change as what? Base number only. What is the answer will change as what? That will be your argument, right? So equal to x. So what is the x value now you are getting? Log 3 to the base 7, right? Next, we'll see the quick recap about whatever we learned it. What we learned first? We learned the real numbers, right? What is the real numbers? When the numbers can be written in the form of p by q, that you will say it as what? Real numbers. Then rational numbers included what are the things? Fraction, terminating decimal, non-terminating and repeating decimal. We learned about recurring and repeating is same only, right? What is irrational number? The number cannot be written in the form of p by q. We'll say it as irrational number. And all the numbers or the irrational numbers we will consider under what? Root. Okay. Then we learnt about the relationship of HCF and LCM, and we learnt Euclid's lemma division, right? Then we learned the logarithm. What we learned in the logarithm, when the base and the argument is same, you will get answer as 1. Log 1 is 0, right? Then what are the laws? We learnt it over here. Log m plus log n gives you log mn. Same way, log m minus log n gives you log m by n. If I'm having the power, right, for the argument, then it will be x log m, right? Then we learnt about what is characteristics and what is mantissa. So always the log base should not be equal to what? 1. Okay. By this, I hope so you understood the real numbers very clearly. Thank you very much.